Speech processors uh, allow you to emphasize some frequencies more than others. So you can uh, put the, you can change the area under the curve of the modulating waveform. So you can get more power and make it more intelligible. Uh, One thing I've learned since I have hearing aids is when you start to have hearing problems, the problem is you've lost the high frequencies. So in order to make it more intelligible, all they do is boost the high frequencies again. So that's essentially what you're doing here and making it more intelligible. But you also get more average power out because of the way you reshape the modulating waveform.
And also, when you're trying to do the pilot, you can actually tune slightly off frequency. So you have a little bit more high frequency range. Then they think, "Ooh, that station's further away."
What is the purpose of a speech processor in a transceiver?
Yeah. Oh, I've increased loud apparently.
Right. You're not talking any louder, but you're making it appear that you are. How does the speech processor affect a single sideband phone signal?
Increases that.
Right. All right. If you incorrectly adjust your speech processor, you can cause distorted speech, splatter, because you're over modulating, uh, and excessive background pickup. I'm not sure I understand that. Why that?
So if someone is sitting, 3 feet from your box mic and your box mic is hearing them fine, you're also hearing everyone else in the house. The parakeet, the dishwasher.
Well, I understand that, but what's that got to do with adjustment of the speech processor?
The speech processor can have a gain function in it, and it is a compressor a lot
Okay.
of times.
Okay.
So you bring the little noises up to the, yeah.
What is the effect of an incorrectly adjusted speech processor?
All the above.
All the above. S meters. I should have put a picture. I don't think I have one there. Oh, yeah, I do. It's a display or indicator on most of the receivers that indicates the relative signal strength of received signals. In actuality, what it's measuring is the automatic gain control voltage, which is proportional to the signal strength. But the bottom line is it's a relative indication of signal strength. We do it in what we call S units up through S9. They're logarithmic. Each S unit is approximately a 6 dB increase, or 4 times. One, go ahead.
I don't like that 4 times without putting 4 times what? 4 times power.
4 times the previous S unit. So S9 is 4 times S8.
Yeah.
16 times S7.
Yeah.
Until we get to above S9, and then it's 10 dBs. So here we have 0 through S9 over here on the left part of the meter. And then once we get S9 plus, we're going to go 10, 20, 30, 40, 50 dB. And these are actual, 10 dB, which is 10 times 20 dB, 100 times, 30 is 1,000 times what S9 is. So when they say S9 plus 20, the signal is 100 times what the S9 signal was.
They're from the old days too, you just say S9 plus or plus.
Yeah. Well, and if you got a handy talkie like mine, I don't have an S meter, I just have bars. So it's either full bars or not. What does an S meter measure?
Two signals.
Receive signal strength. How much change in signal strength is typically represented by one S unit?
dB. dBm, dB.
dB, it's just a ratio. So it's 6 dB more than the previous one.
But your antennas are thinking what?
Well, the fact that they don't say dBm or anything is because it's a relative, uncalibrated indication.
Okay, about the sun caliber.
You can go to a lot of stuff and calibrate your S meter, but most of them are approximate, the relative indications. So my S9 may not be the same as your S9.
All right.
How much must the power output of a transmitter be raised to change the S meter reading on a distant receiver from S8 to S9?
Probably
4 times or 6 dB.
cappuccino.
And right now I've got neg 87 dBm signal strength on my phone.
Okay. Above S9, the S meter is calibrated in dB, and we say if it's more than S9, we just say over S9, or you can say 20 dB over S9, which would be 100 times more powerful. Because we all remember 20 dB is a ratio of 100, right?
I always remember that.
Okay.
I see it like this. That's all I dream about.
10 times the log of 100, which is 2. Oh, and there's all meter again showing the S9 plus values. This one also has a dBm meter. Whether or not it's calibrated, I don't know. But in this case, I would say that S9 is corresponding to a minus 70 dBm. So that's pretty low signal. How does a signal that reads 20 dB over S9 compare to one that reads S9 on a receiver, assuming a properly calibrated S meter?
Charlie.
Yep. No.
20 dB.
Oh,
10 to the 2.
yeah, D.
Single sideband, upper and lower. Normal single sidebands are approximately 3 kilohertz wide. The lower sideband will be 3 kilohertz below the suppressed carrier frequency. The upper sideband is going to be 3 kilohertz above that carrier frequency. Example is the general 40 meter band, which goes from 7.175 to 7.290. So if you're in that band, you should tune to 7.178 megahertz or higher for lower sideband because you want to be 3 kilohertz above the low end. Or in the other example, you tune to 7287 so that you're 3 kilohertz below the upper end of the band.
What's your CW or data? Unit closer?
Well, yeah, but we're talking SSB.
Yeah.
3 kilohertz. And actually, I think it's more like 2.8, but they use 3. That's good. How close to the lower edge of the phone segment should your displayed carrier frequency be when using 3 kilohertz wide lower sideband?
Above.
All right, 3 above. What frequency range is occupied by a 3 kilohertz lower sideband signal when the displayed carrier frequency is set to 7.178 megahertz?
Right. 7.5 to 7.8.
Right. You know, it can't be D because it's got to have a 7.178 in it, either higher or lower than that. How close to the upper edge of the phone segment should your displayed carrier frequency be when using 3 kilohertz wide upper side? So you want to be 3 kilohertz below the upper edge of the band. Yeah, that actually should say upper edge.
It's how close to the upper edge.
Well, I know, but the way they worded it, you can say, well, I'm 3 kilohertz below the lower edge.
But you have to put into the context of the question.
I understand. What frequency range is occupied by a 3 kilohertz upper sideband signal with the displayed carrier frequency set to 14.347 megahertz?
Bobby.
So we're 14.347 and we're upper sideband.
350.
347 plus 3 is 350.
Give them the band village.
All right.